Okay, hi everyone. So we're on lesson 2 of the Surds recap today. So we're going to be looking at calculating with Surds. So yesterday we looked at what Surds are and how we simplify with them. We'll be using that today, but we're going to be going a bit more advanced with it as well. So the first thing we're going to look at is how we do multiplying with Surds. Now we did look at this kind of yesterday when we looked at the Surd rules. So a quick recap of the rule that's going to apply with this will be, it is the one where it is root A times root B. We can write it as root of A times B. So it kind of makes sense if you're timesing two square roots together, you can write it as the square root of those two things. So rather than having them separate, you can write them together. So that is what we're going to use for the first few. So we've got root 3, so starting over here, we've got root 3 times root 5. So we use our rule, so we've got root of something times the root of something else. We can write that as root of 3 times 5, so root 15, if we were to write that as one square root. So we've not seen one like this yet. This is 2 times root 3. This is fairly straightforward. We just write that as 2 root 3. So you can think of this, when there's a square root, you can kind of think of it as an algebraic thing. So it'd be like if there was 2 times x, you could write it as 2x. It's the same kind of idea. Basically, you can't mix the square root things with the non-square root things in this case. So over here, next one down, we've got root 5 times 3. A really common mistake here would be to write root 15, but it's actually the same kind of idea as the one above. We've got a whole number times by a square root, so again, it's going to be, so it'll be 3 root 5. For the same kind of idea, if you had x times 3, it would be 3x. Okay, next one, so we've got root 2 times root 8. For that one, we can use our rule from up here. So root 2 times root 8 is root of 2 times 8, root 16. So you'd get a method mark for getting here, but to get the final answer, root 16 is 4. So this is quite a common sort of question where you have to do the multiplication and then simplify. So just something to be aware of. So root 3 times root 3, again, you can use our rule. So we could do root of 3 times 3, or root 9, which is 3. The other way you could think about this one is if you've got a square root of something, if you times it by itself, you get back to the original thing. So if we have square root of 3 times square root of 3, that would just be 3. So if you can just spot that one, that's great. If not, you can do it using the Surd rules. Okay, so these ones are a little bit more difficult, and the reason is we've got a number now in front of the Surd. So we've got 2 root 3 times 2 root 5. So this is kind of again similar to if we were doing it with algebra. So with algebra, let's say we had 2x times 2y. We times the numbers and then we times the letters, so we end up with 4xy. Again, same idea with Surds. So if we've got root 3 being x and root 5 being y, so we've got 2 different Surds there, so we can't mix them yet. So we've got 2 times 2, which gives us 4. We've got root 3 and times root 5. So we can actually use our rule here. So root 3 and now root 5, so I'll write it out in full, but then we can simplify that down. So we've got 4, and then root 3 and root 5 are times together, so we can use our rule to get root 15. And then we'll check if we can simplify that one, but in this case we can't. There's nothing we can do to simplify that. Okay, so next one down, so just drawing your attention to this rule here. So multiply the non-surdy things. I'm not sure surdy is the correct word, but you'll know what I mean. Multiply the non-surdy things first, and then the surd things. So non-surdy things, we've got 3 and 3. So we times them together and get 9. And then we've got the non-surdy things, we've got root 2 times root 2. So similar to up here, root 2 times root 2 would actually just give us 2. So we end up with 9 times 2, which is 18. So you can see we've times together 2 surds and got a non-surd. Can happen, just something to be aware of. And this last one down here, we've got 4 as our non-surd thing, so we've got 4. And then we've got root 18 times root 2. So using our rule for the surds, we've got 2 surds times together, so we can have the square root of them. So that would be 4 root and 18 times 2. And then, so that's 4 root 36. So we can actually simplify root 36 to 6, so we end up with 4 times 6, which is 24. So a whole bunch of examples on multiplying there. So loads of examples. So if you do need to go back and watch any of them for practice, you can do, but it should be a recap mostly. And with division, the concept's really similar. Again, we're using one of our surd rules from yesterday. We're actually just focusing on the second one now. So we're doing, so if we have a square root of something divided by the square root of something else, that is equivalent to the square root of that fraction. So similar to the multiplication one, we can use this to work out division surds. So if we've got root 15 divided by root 5, so we can write that in this form, so root 15 over root 5. So you can see we've got a square root of something divided by a square root of something else. We can write that as the square root of, and then 15 over 5. So that would be square root of 3. So similar idea to multiplication, we're just using the rule that we looked at yesterday. So this one, there's a couple of different ways of doing this. I'll show you both ways, but I'd probably stick with just using the rule for this one, but I will show you other ways as well. So we've got root 27 divided by root 3, so I'll write it in the fraction form. Then we can write it as square root of 27 over 3. So that'll be square root of 9, and then the square root of 9 is just 3. So the other way we could do that would be if we simplify root 27 first, that becomes 3 root 3 using what we did yesterday. So method 2, so we've got 3 root 3, and then we're dividing that by root 3 over here. And then from that we can just see that we've got a common factor of root 3, which can cancel to leave us 3. So 2 methods, you get the same answer for both. So you've got method 1, which is just following the rule. Method 2, if you simplify, you can do it a slightly different way. Okay, and one last one. So what we've got here actually is one where we're dividing a non-surd number by a surd. So we've got 3 divided by root 3. So again, there's 2 different ways of doing this. I'll show you both. So what we can do actually is write 3 as a surd. So what we need to do to represent it as a square root, we need to think what number square roots to give us 3. So 9 is the number that we're square root to give us 3. And then on the denominator, we've not changed that, so it would stay the same. So we've got, on the numerator, we've got square root of 9. On the denominator, we've got square root of 3. So all we've done there is converted 3 to being a square root number. So now we can apply our rule. So we've got a fraction with square roots. We can now write that as square root of 9 over 3, which is just root 3. So that's method 1. I think if you're still a little bit shaky on surds, this is probably the method I would have recommended for this, because you are just following the formula. You just need to convert 3 into a square root. Method 2 would be, if you're a little bit more confident with square roots and sort of what they are, you could write 3 as square root of 3 times square root of 3. Because the square root of 3, if we square that, if we times it by itself, that just gives us 3. So instead of replacing 3 with root 9, we can replace it with root 3 times root 3, and then what we're dividing by, root 3. So then, similar to the one before that we did over here, you can then just cancel out root 3's and you end up with the same answer, method 1 or method 2. But you can see that the formula that we use is really useful because it can answer these harder ones as well without having to sort of think outside the box too much. You can just follow the formula. So as long as you're confident with those 2 formulas we did yesterday, you can actually do a lot of surds just using those. So if you want to have a bit of a practice before you have a go at Dr. Frost, you can have a go at these ones. If you do want to just keep watching the video, go on to addition, and then have a go at the Dr. Frost after, that is fine as well. Okay, the second calculating the third skill we need is addition and subtraction. And what's good about this is it's very similar to algebra. So if you're confident with algebra, this isn't too different. You can pretty much just replace the square root bits with x's or y's and then treat it as if it was algebra. So if we've got root 3 plus root 3, what I want you to instead think is, what do I have if I have x plus x? So we know that x plus x is 2x, so it's 2 lots of x. If we have root 3 plus root 3, we'd just write that as 2 root 3. It is 2 lots of root 3, or 2 times root 3. So you can see it's really similar. And we're going to use that same thinking to work through these other ones as well. So if we've got, the key thing actually here is these are both x's because it's the same number in the square root. If it was root 3 plus root 5, you'd have to use x and y because that square root would be different. So like if you've got different algebraic terms, if they're not the same, you don't use the same letter. So let's have a look at this one. So first thing we can see, we've got root 5 for both. So let's think in terms of x's and y's. So we've got 2y plus y, which would be 3y. So in this case, if we've got 2 root 5 plus root 5, just would be 3 root 5. So really, really similar to algebra. So if you want to have a think about this next one. Okay, so if we've got 7 root 7 plus 7 root 7, that would be like 7x plus 7x, which would just be 14x. But in this case, our x is root 7, so 14 root 7. So quite straightforward. And now we get to our first sort of challenge one. If you want to pause and have a go at this, you can do. The hint would be that we're going to be using what we did last lesson. So if we've got root 2 plus root 8, we can see we've got different square roots, so we've got basically x plus y here. So we can't simplify that. But is there something we can do to root 8 to get it so it is in terms of root 2? Or we can simplify it. So root 8, if we simplify that, we look for a square number that is a factor of 8. So we've got 4. So we can write it instead as 4 times 2. So then that would be root 4 times root 2. And then root 4 just becomes 2. So it would be 2 root 2. So what this question is really asking is root 2 plus 2 root 2. So now you can see we've changed our surd to being the same square root in each. So now we can just do it like with x's like before. So it'd be x plus 2x, be 3x, or in this case 3 root 2. Okay, so you can start to see how similar it is to algebra. So it's a really useful way to think about this. I think it's still how I do it. I think back to algebra and then go from there. Okay, so last one on this section, 3 root 12 plus root 27. So you can see with this, again, it's a different square root, so we're going to have to get around that. So let's simplify them and see if that helps us out. So root 12, we can write that as root 4 times 3, which is root 4 times root 3, which is 2 root 3. We can't simplify it anymore because there's no square number of factors of 3. So now let's do 27. So 9 is a factor of 27 and also a square number. So we use 9. That gives us root 9 times root 3, which is 3 root 3. So now we can see we've got a root 3 in both, which is a really good sign. So let's substitute those back in. And bear in mind, we've got 3 lots of root 12. So we've got 3 lots of, and then 2 root 3, which is what root 12 was. I'll put that in brackets just so now it's separate. And then we're adding root 27. So there's no number in front of that, so we don't need to worry about that. It's just this whole thing, 3 root 3. Okay, brilliant. So nearly there now. So if we've got 3 times 2 root 3, that would just be 6 root 3. So that would be as if you had 3 times 2x, it would be 6x. And then we've got add 3 root 3, and nearly there now. So we've got 6 root 3 add 3 root 3. So thinking 6x plus 3x, that would just be 9x, which is 9 root 3. So you can see it's a really powerful technique if you start thinking of surds in terms of algebra. It's a really good way to think about it. It'll get you really far with the addition and subtraction ones. Okay, so here's a few to think about if you want to have a practice at this before you go on to the Dr. Frost. If you do just want to go to the Dr. Frost from here, that is completely fine. Okay, and here is the answers for those ones. Okay, so if you want to go on to the Dr. Frost, you can do. This next little bit of the video is completely optional. It does sometimes come up in tests and on homeworks, but it's not technically on the Year 9 scheme of work. So if you don't want to do this next bit, that's fine. You can go and do the task. You don't need it for the task. If you are interested and want to do this last little bit, that is fine. Okay, so this one is expressing something as a single square root. So it's kind of the opposite of simplifying. So I've called it unsimplifying. So basically, it's going from a simplified surd to just a single square root. So we'll start off with this one, and then I'll leave the last three to do as practice. So we've got 3 root 2. And we remember when we're simplifying, we started off with some number, and then we used our rule to split it into 2, where one of them was a square number, and then we could write it just in the form something root something else. So what we're going to do is start in this form and kind of go backwards. So we're starting with something in front of the brackets and something in front of the square root and then something in the square root. So what we need to do is go from this step to the step before. So we need to get the something in front of the brackets, something in front of the square root and put it into a square root. So if we have 3, what would that be? What is equivalent to 3 but in a square root? So basically, what number do we square root to get 3? We could write that as root 9. So that's what we'll do. We'll go from 3 root 2 to root 9 root 2. And then from here, we can go back again. So using our sort of surd rule number 1, that takes us to root 9 times 2. And then from there, we can go root 18. And we can see we've gone from a simplified surd here to a single square root there. So this is just doing the same steps as simplification, but backwards. So if you want to pause and have a go at these last few, I will go through them, but if you want to pause and have a go at these, you can do to get the extra practice. Okay, so 2 root 5. So we need to work out how could we write 2 as a square root. So if we have 2 root 5, we really want this to be, so basically what number do we square root to get 2? 4. So we've got root 4 times root 5. And then using our surd rule, we've got root 4 times 5, so root 20. So we can see we've gone from simplified form to the unsimplified form. Okay, so last couple, I'll go through these ones quite quick. So if we've got 5 root 7, we can write that as root 25, because that is 5 root 7. And then we just do 25 times 7, so that is root 25 times 7, which is root 175. And last one, 4 root 3. So what number do we square root to get 4? So that's square root of 16. And we've got 3 there. And then use our rule, so 16 times 3. So root 48 would be our final answer for that one. So as I said, this isn't on the Year 9 scheme of work, but it is really useful for understanding surds. So I would recommend at least having a look at this, because it will come in useful next year or year 11 as well. It will come up at some point. If you can get ahead now, that is great. So well done if you've watched this bit, and good luck with the task.